Okay, class, here is your bell work for today. It's an introduction to lesson 4-8. It asks what type of graph does each set of points resemble. You got to tell me whether they're, you can look up on the parent function chart and see which one it resembles, but like, are they linear, are they quadratic, are they exponential, what are they, okay? So I'm going to pause this for a moment while you I'm going to have the substitute pause this for a moment while you look over this and decide on your answers. And also I want to point out that your itinerary is on the back whiteboard for November 28th. We are going to, first of all, do the bell work, which is an introduction to 4-8. Then we're going to grade in and turn in our homework for lesson 4-3. Then we are going to review homework 4-5. I'm going to just do one problem from those 5 problems we did. I think a lot of you finished the assignment already. And then I'm going to give lesson 4-8, and then you're going to have time to do your assignment for problems to do. But we're going to be modeling equations today. So I'm going to pause this while you do the homework. And I'm going to pause it while you do your bell work. Okay, these graphs, if you look at number 1, if you were to draw a curve that kind of goes through the middle of all this, it would be a quadratic equation. It would graph a parabola. So this model is a quadratic function. Number 2 follows this kind of a pattern right here. And we would say that that follows a cubic pattern. And number 3 models this data right here. We say that it follows a linear pattern. We are going to be using these on the assignment 4-8 today. You're going to have to plot some points on a graph. We've done this once with linear equations before, but you're going to plot some points on a graph and decide, is it modeling a linear function, a quadratic function, or a cubic function, or an exponential function, or what kind of data, what kind of graph is this data modeling? So we'll be doing that on the assignment today. Okay, we are going to now grade the homework on 4-3. So I'm going to pause this for a minute while you get that out. Okay, did problems 14 through 27 all on lesson 4-3. So I put into the calculator to choose, we're going to choose 5 problems between 14 and 20. We're going to do number 21, 18, 27. We already did 18. We're going to do 25 and 14. So I'm going to write those down right here. These are the problems we're going to correct. 14, 18, 21, 25, and 27. Trade papers right now. So if we need to pause that for a second, go ahead and do so now. Okay. You should have traded papers by now. You should have 14, 18, 21, and 25 circled. We are going to do number 14, the answer to number 14. After you do the division, you should have gotten x plus 13. Could have been ending polynomial. Number 18. The answer should be 3x cubed. Let's see, minus 5x squared. plus 10 I think that's supposed to be 10x minus 14. My book showing it wrong. With a remainder of 12. Number 21 is 0 and yes. That means the remainder was 0, and therefore um, x plus 2 is a factor, and that's why they said yes. Yes, it is a factor. Okay, number 25. The answer is 0 and yes. And number 27. The answer is the square root of 6 to the 4th minus 36. Or in other words, 36 minus 36, which is 0. So the answer is 0. You should have gotten the square root of 6 raised to the 4th power, which is going to be 36. And then you minus 36, and then you get 0. So you could have just plugged square root of 6 in for x, raise it to the 4th power minus the 36, and you could see that you could get 0 that way. All right, put a score out of 10 on your paper and go put it on the flapper board. And if Candace, if you'll gather those up afterwards and put them in the cubby hole, I'd appreciate it. Okay, I am going to go over one problem from the 5 problems we did on lesson 4-5. And I don't have any idea which one you guys want to go over, but I'm just going to pick number 5. Okay, here's number 5 from the homework. I am going to I have to find complex zeros. That means the real zeros and the imaginary zeros. I'm going to start off by finding the real zeros by putting this function into my calculator. So x raised to the 4th power minus 7x cubed plus 14x squared minus 38x minus 60. So I'm going to graph this on a standard window, so I'm going to hit zoom, and then number 6 is standard, so I'm going to hit 6, and I have a standard window there. I can see at least 2 real zeros, in other words where it crosses the x-axis, just to make it easier to find the zeros when I do this. It looks like it's -1 and 1, 2, 3, 4, 5, 6. We could just, we're gonna assume that it's -1 and +6 right now. Okay, so I am going to go over -1 and 1, 2, 3, 4, 5, 6. -1 and 6. We're going to say that x equals -1 and x equals 6. And divide those in synthetically. We'll know if they work by whether we get 0 as our remainder or not. So we are going to set up the division right here. I'm going to choose -1 first. Remember, you don't put the opposite sign in there. You put -1 in there because it's not written as a factor. Then I write the coefficients of x to the 4th as 1, of x cubed is -7, of x squared is 14, of x is -38, and the constant is -60. I bring down the first number, which is 1, and I'm ready to begin the synthetic division. I multiply -1 times 1 and get -1. I add, I get -8. I multiply -1 times -8, and I get a +8. I add, and I get 22. I times -1 times 22, and I get a -22. I add, and I get a -8. 60. I multiply -1 by -60, and I get a positive 60, which I add, and I get 0. Therefore, -1 is a root or a solution to that function up there. So I know I chose the right number. Now I'm going to divide 6 into that. So I put 6 out there, bring the 1 down, and I'm ready to begin. 6 times 1 is 6. Add -8 and 6, I get -2. 6 and -2 is -12. And I add that, and I get 10. 6 times 10 is 60. I add, I get 0. Therefore, I also know that 6 is a root because I got 0. And I have my coefficients for my quadratic function, 1, -2, and 2. So I'm going to write that out. X squared minus 2x plus 10 equals 0. And I can find the other two roots, which we're going to assume are imaginary. Since we know it's 4th degree, we have to have 4 roots. And I have the two real roots as -1 and 6. I'm going to solve this quadratic equation using the quadratic formula to find the two imaginary roots. And so I know, when I do this, that A equals 1, B equals -2, and C equals. So I go to my quadratic equation. I go -b, which would be a positive 2. It's the opposite of b, which is positive 2, plus or minus the square root of b squared. Well, -2 squared is going to be a positive 4. Anytime you square a negative number, it becomes positive. Minus 4 times a, which is 1, c, which is, and divided by this. I know that 4 times 1 times 10 is 40, and 4 minus 40 is a -36. Okay, here is today's lesson. Everybody needs a graphing calculator, and anytime you need to pause this Canvas to make sure everybody's up to the same spot, go ahead and do that. But you need to follow closely, students. So make sure you've got your calculator ready to go. And if you're having problems with your calculator, it's probably because you input something wrong, but then just watch off your neighbor for a little bit. We can rewind it and redo it, but I'll try to point out some of the common problems students have when we do this. All right, we're going to write polynomial functions to model real-world data and interpret the data. Right here is a graph. This is actual data from the years 1980 to 2001 of the pounds of waste per person per year in the United States of America. So you can see that in 1980, the average person had 3.7 pounds of waste per day. And in 1985, it was 3.8, 1990, 4.5, 1991, 4.4, 1992, 4.5, and so forth. Up to 2001, it was back down to 4.4. Okay, so we can kind of see a little bit of a trend. And you could probably kind of guess what kind of graph this models before we even graph it, if you think about it. Okay, so we are going to go ahead and put this into our calculators right now. Someone might have to get up here and read these, but I'll read them off as we go through because you probably can't see them where you are. Okay, I want everybody to go to your y screen and clear everything out. I want you to make sure that none of those plot 1, 2, or 3 at the top of the calculator are highlighted. Okay, we are going to turn on plot 1 here in just a second, but if you have more than one of them highlighted, then you're going to have problems. Okay, and that's one of the common errors. Okay, then we are going to go, we're going to hit the stat button. Stat button is just below the delete button. If you see that, if you know where that one is, it's on the second row, the third one to the right. Stat button. And this is what the screen should look like. We've done this once before, so hopefully you remember it. If we go into edit, number 1, hit enter or 1, it brings up these things right here. Now, hopefully you have list 1, list 2, list 3. If not, you can use whatever lists are up there. But what I would do is go to the right and make sure everything else is cleared out of there. Okay, so it looks like nothing else is under my, I have 6 lists there and nothing else is under any of the other ones. Make sure yours is the same way. Now, if you don't have L1, L2, and L3 at the top, but you have other ones, just use those and I'll show you where to change it later on. But I'm going to go up to L1 and I'm going to hit clear and go down. It will clear out all that data that's in there. Now I'm going to go over to the L2 list, go up to L2, highlight it, hit clear and hit the down button, and that will clear that list. So go ahead and make sure all your data is cleared out of there. All right, now what we're going to do under list 1 is put the dates. 1980, 1985. Now we have what we're going to do right here is we're gonna put in the full years because 1980 and then it goes to 01. The calculator might not understand going from, if we just put in 80 and then put 01, it wouldn't understand that. So we're gonna hit 1980 for the first year and hit enter. Next one is 1985. Put that in and hit enter. The next one is 1990. Hit enter. The next one is 1991. The next one is 1992. The next one is 1993. 1994. 1995. 1996. And then it jumps clear up to 2000. So 2001. Enter. Okay. You might want to double check your date. Make sure you got it in right. Hit the right arrow button and go over to list 2. And we're going to put in the pounds of waste per person per year. In 1980 it was 7, so hit 3.7 and enter. Then 3.8, enter. 4.5, enter. 4.4, 4.5, year are we on? 1993, it's 4.5. And then 4.5 again. And then 4.4. Whoops, I did something wrong. I didn't hit enter after one of mine. I gotta go back to 1994 and put in 4.5. Back to 1995 and put 4.4. 1996 and put 4.3. And then to 2001 and put 4.4. All right, there is my data. Now we've got to find a window that will show this data. So everybody hit your window button. And by the way, if you're having problems with your data, I'd go through and double check it right now. We can pause it if you need to and check your data and make sure it's correct. Okay, everybody hit your window button. Right now we have a standard window, at least I do. You might have something different. Okay, but we just did that other problem, so you should have the same as I do. Okay, our X min, well, our smallest year, remember X is the years, X represents the year. My smallest year is 1980 and my largest year is 2001. But we are going to make a prediction out in the future based on this too. So hit 1978 for my X min. For my X max, we are going to put in maybe, let me check the problem and make sure how much we're going to do it to. I think we are going to predict, well, we can predict what we want. We're going to predict into the future. Let's say 2000. So 2011, 2011. I'm going to hit enter. And from 1978 to 2011, I'm going to put the years go up every 2. So my X scale is going to be 2. Every 2 years it will show a mark. Okay, for my Y min, my lowest value is 3.7. But it looks like there might be a trend that the pounds, the waste per person is going down slightly. So we are going to guess that, and we're going to start maybe at 3. 3 pounds per person is my min. Well, my max, the most that it is 4.5. Maybe we'll go a little bit higher than that. And I am going to put the Y scale at 0.1 because we're only going to 3 to 4.7. So I'm going to put a mark every 0.1. That's between 3 and 4.7 is 17 marks. I'm going to hit, oh, we got to turn on our stat plot first. So everybody hit second and Y equals, and it will bring up the stat plot. So hit second and Y equals. If you need to pause that for a second, go ahead. Okay, on second and Y equals, we have the stat plot. We need to go into number 1. So since it's on number 1, and the other ones should all be off. But go into number 1, and we're going to turn it on. And we are, notice on mine, the type of graph is the very first one, which is, whoops, the first one, which is points. You should have that chosen too. Okay. Now, my X list is L1 and my Y list is L2. If you didn't have an L1 and L2 on your calculator and you had to put them in under different lists, then at this time you need to change that. And if you'll notice, above 1 and 2 and 3 and 4 and 5, it has the L1, L2, so you have to hit second and L1, second L2, whatever, to change your X list and your Y list if you have something different. Go ahead and pause it if we need to right there. All right, and then you have to put a mark. The first mark is the best mark to see. The second mark is the second best to see, and the third mark is hard to see most of the time, so don't use that one. Okay, the mark is the first one. All right, I'm going to hit graph now. There are my points. Well, I'm looking at that and thinking, man, they're all over the board. That doesn't really resemble anything. Okay, however, the book suggested that it resembled a quadratic, an upside-down quadratic. So we're going to use a quadratic to model it. No, I could see how someone might want to use a cubic to model it a little bit too. You could probably do that. But they're guessing that the trend is actually going down. So you might want to just do what they're doing is using a quadratic. So this is what we're going to do. If you hit go to second and hit mode to quit and go to the home screen, clear that out. Okay, and we are going to hit the button stat. So hit your stat button. If you need to pause right there, go ahead until everybody's got it. So go one to the right to the calc menu for stats. And we are doing a quadratic regression. That's number 5. It says quad regression. So hit number 5. And it pastes that to the home screen. And now if you hit enter, your coefficients, A, B, and C. And there is your equation. So we're going to round this to the nearest thousandth and do this. So I'm going to write it down. Y equals 0.00 squared. And then 13.552x minus, put this number down here, 13,519.71 or 707 if we go to the nearest thousandth. Now I did show you guys another way to get this into y equals, but I think this is the easiest way since I'm not there. Okay, so go to your y equals now, and you're going to type that equation in there. 0.003 x cubed plus 13.552x minus 13,519.707 and hit graph. Whoa, my graph did not show up there. Did something wrong? Let me look at my graph, see if I put it in right. 0.003x. Oh, I put cubed. You guys probably noticed that right when I did it. Squared plus 13.5x. Okay, should show up now. Unless I did something else wrong. Okay, I did something else wrong. 0.003x squared plus 13.552x minus 13,519.707. It looks right, unless you guys see something I did wrong. I wonder if it has something to do with the way I put my x squared in there. I'm going to delete this and hit insert squared. Okay, we're trying that one. I need to go back to my coefficients and look at that. Oh, that's a negative. That's what I did wrong. It's a negative 0.003x squared. Okay, so go back to my y equals, and I'm going to insert, hit second, and the delete button, that insert. I'm going to put a negative in there. You guys probably caught that right off. Hit graph. And now, hopefully, oh, man, what did I do wrong now? negative 0.003x squared. I got to go back and look at this again. Negative 0.003 plus 13.552 minus 13,519.707. I think everything's right. Go back to my y equals negative 0.003x squared plus 13.552x minus 13,519.707. Okay, we're going to try a different way. Because that, let me just try it one more time. See if we graph. Okay, we are going to go back and clear that out. This is the old way I showed you. This one should get it right on. Okay, so go to your y equals, hit the vars button. Okay, vars is right next to clear. Pause it if you need to. Go to number 5, statistics. Go over to EQ. And to number 1, regression equation. And it will paste it in there. So this time it should graph it because that's the actual equation. Okay, there it is. It might have been that my coefficients were just, when I rounded it to 3,000ths, it just wasn't close enough. Okay, there is my quadratic function of best fit, okay, or my regression equation that models this data, although I don't think it's a very good model. Okay, I got this one out of the book. I was assuming it was going to be. And by the way, there's not a wrong answer if you think it's doing something else and you choose a different model. There are on some of them, but a lot of them, it's just fine to choose whichever one you think fits best and which way you think the data is going. Okay, so there is my data. Now, I'm going to make a prediction in the future because this is what you're going to do. You're going to have to make predictions on your functions that you do. You're going to be doing 4 homework problems. So here we go. I'm going to make a prediction in the future. So what I do is I hit second and the trace button to bring up the calc menu. And I'm going to go to value number 1. And I'm going to put in 2010. I'm going to make a prediction for 2010. So the amount of I want to know, based on this graph, what's the amount of waste going to be in 2010 per person. I hit enter. And it tells me it's going to be about 3.78. I don't know if that's the actual amount. If someone wants to Google it and see what the actual amount of waste per person is, that would be great to see. Okay, but that is about 3.78 is the prediction that we're making. And that's the whole idea of modeling real-world data, is to come up with an equation that models the data so that we can make future predictions. And that's what mathematicians do with this information. Okay, we're going to move on a little bit here. I just wanted to show you this graph again. We kind of talked about it on the bell work, but the type of equations you're going to be modeling today are either going to be linear, quadratic, cubic, or to the 4th power, which we call quartic. And so most of your functions will model one of these 3 things right here. So as you'll notice that I put down here direction changes. A linear equation has 0 direction changes. Quadratic has 1. Cubic has 2 direction changes. And quartic has 3 direction changes, or can have that many direction changes. So you can look at that for a second. If you need to pause it, go ahead. Okay, if you were looking at this data, this is like the bell work problem. Which function would you use to model this data? Well, the first one, I'm guessing most of you are saying cubic. And you would be right. The second one, I am guessing you would say quadratic. And the third one, I'm guessing you would say linear. And those are the functions. So today, for your homework assignment, you have 4 problems. You're going to put the data into your calculator. You are then going to get a graph of that stat plot. You're going to decide what kind of function that the data models, like a cubic, linear, quadratic, and so forth. Then you are going to find the regression equation for that. If you need to go back, rewind this a little bit to see how I did the other one, go ahead. And then you are going to make a prediction in the future on each of these. So you can pause this if you need to write it down, but this is the end of the lesson. I'll do one of these problems next time as an example, but you've got to do the others, and I'm not saying which one yet. So anyway, work on these. You have the rest of the class period to do so. Good luck. Bye.